Floating between Mars and Jupiter is a fortune estimated at $10 quintillion. It is enough to give every human on Earth $100 billion. But this is not a story about getting rich. It is a story about how the pursuit of infinite wealth will crash the global economy, destroy the mining industry, and ultimately save the planet. From the garage startups of 2025 to the starships of the 22nd century, this is the timeline of the Great Ascent. 2026. The ignition phase begins. A massive media hype cycle takes over. Tech billionaires go on television promising that the first trillionaire will be made in space. Companies like Astroforge launch their Odin missions, and NASA's Psyche probe reaches the metal world it was named after. We look at the stars and see dollar signs. The reality of physics sets in. We call this the first contact. The first wave of commercial probes attempt soft landings on near-Earth asteroids. Nearly 60% of them fail immediately. We discover that you don't simply land on an asteroid with milligravity. If you touch them too hard, you bounce off into the void. 2027, the engineering teams struggle with the communication lag. Joysticking robots from Earth proves impossible. It becomes a graveyard of good intentions and burned capital. 2028, the Delta V crisis hits. A high-profile startup manages to capture 500 kilograms of ore, a massive technical victory, but then they look at the fuel gauge. To bring that heavy rock back to Earth, they need to slow down, which requires massive deceleration burns. The cost of the fuel is higher than the value of the platinum itself. Investors flee. The industry is labeled a scam. 2030. The garage era begins. The major players fold and the industry goes dark. Small, lean teams of engineers stop trying to impress the stock market and start wrestling with the rocket equation. They realize they cannot beat it with brute force. They need a paradigm shift. 2032. The breakthrough arrives with the Hephaestus 1 mission. It is a one-way trip. A small robotic probe lands on a water-rich asteroid, melts the ice, splits the hydrogen and oxygen, and refuels itself using the asteroid's own resources. It proves the gas station is already there. We stop bringing the rock to the factory. We learn to bring the factory to the rock. 2035. The era of the hero astronaut comes to a quiet end. The insurance premiums for sending humans to the belt become mathematically impossible. The industry pivots entirely to the logic of the insect. We enter the age of the swarm. We stop building massive billion-dollar spacecraft designed to keep fragile humans alive. Instead, we mass-produce thousands of 50-kilogram autonomous refiners. They are stripped of all life support, shielding, and safety margins. They are disposable tools, designed to die in the dark. 2036. The launch windows open. We watch as trains of these glistening satellites are deployed into high Earth orbit. They don't use chemical rockets, which burn out in minutes. They deploy vast, paper-thin solar sails and activate ion drives. These engines produce a thrust so gentle, it feels like the weight of a coin on your hand. But they can burn continuously for years. The Great Migration begins, a silent river of machines spiraling slowly out toward the asteroid belt. 2039. The transit is long and boring. For 3 years, the swarms drift through the void. On Earth, the public loses interest. The hype cycle has died down. Space mining is no longer on the news every night. It becomes background noise, a boring infrastructure project happening millions of miles away. But in the control centers, the telemetry streams are steady. The swarm is healthy. The swarm is hungry. 2040. The swarms arrive at their targets. They don't just land on the asteroids, they infest them. Like termites on a rotting log, thousands of units latch onto the gray rocks of the belt. They utilize swarm intelligence. There is no master controller on Earth joysticking them. The robots talk to each other. If one unit finds a rich vein of platinum, it signals the others. If a unit breaks down, its neighbors cannibalize it for spare parts. The mining process is not loud and explosive. It is quiet, surgical, and relentless. 2042. The processing begins. We don't make the mistake of Era 1. We don't try to ship raw rock home. Inside the belly of the swarm, solar concentrators melt the asteroid regolith. Centrifuges spin the molten slag to separate elements by density. Iron goes here, silicates go there, and the heavy precious metals, gold, platinum, palladium, are printed into standardized, interlocking ingots. The asteroid is being digested. 2044. The return journey begins. The swarms detach from the hollowed-out husks of the asteroids. They are heavier now, laden with the wealth of kings. They turn their ion drives back toward Earth. The return trip is faster, aided by the gravity of Mars. Back on Earth, the commodity markets remain skeptical. Platinum trades steadily at $900 an ounce. The terrestrial mining giants in Russia and South Africa are still digging deep shafts, confident that space gold is just a myth that will never arrive in significant quantities. 2045. The first hive enters high Earth orbit. It parks itself in a stable gravity well. It doesn't bring back samples. It brings back tonnage. A single payload contains 2,000 tons of platinum group metals. To put that in perspective, that is equivalent to 10 years of total global production mined on Earth, arriving all at once. The shadow inventory hanging over our heads is suddenly real. 2046, the logistics of re-entry begin. We don't drop the whole payload at once. That would cause a kinetic catastrophe. We use safe re-entry pods, small foam-shielded gliders that can carry 100 kilos at a time. The sky over the recovery zones in the Nevada desert becomes a highway. Day and night, parachutes open. The trickle of metal becomes a stream, then a river. 2048, the aluminum moment arrives. The markets finally do the math. They realize scarcity is over. Historians smile because they have seen this before. In the 1850s, aluminum was the most valuable metal on Earth, more precious than gold, until we figured out how to refine it with electricity. Overnight, it went from the dinner plates of emperors to the siding of cheap houses. In 2048, this happens to platinum. The price crashes from $900 an ounce to $5. The mining stocks on the New York Stock Exchange plummet to zero. Panic sweeps the financial sector. 2050. But out of the panic comes the revolution. The hydrogen economy, which has been stalled for decades, suddenly ignites. Hydrogen fuel cells require platinum as a catalyst. For a century, this made them too expensive for mass adoption. But now platinum is cheaper than copper. The cost of a fuel cell stack drops by 99%. We stop burning gasoline not because we pass laws against it, but because the clean technology becomes dirt cheap. The crash of the mining market becomes the birth of the Green Age. 2055. As the economy stabilizes, humanity faces a new physics problem. We have infinite resources in space, but we are still stuck at the bottom of a gravity well. We realize that dropping billions of tons of iron and steel down to Earth is thermodynamically stupid. The heat generated by re-entry requires expensive heat shields that eat up all the profits. We make a decision to split the global supply chain. The high-value, low-weight items like gold and electronics go down to Earth. But the heavy materials, the iron, the nickel, the titanium, stay in space forever. 2058. We stop launching space stations from Earth. We start building them in the void. We utilize a technique called vacuum cold welding. On Earth, metal has an oxide layer that prevents it from sticking together. In the vacuum of space, if you touch two pieces of clean metal together, they fuse instantly into a single solid piece. Construction becomes faster, stronger, and cheaper than anything possible on the ground. 2060, the ugly ship era begins. For the first time, we are building vessels that never have to enter an atmosphere. We stop building rockets that look like needles. We start building bricks. Massive, asymmetrical orbital shipyards float above the planet, looking like oil rigs in the sky. They are purely functional, covered in scaffolding and sensor arrays, with sparks from automated welders drifting endlessly in the vacuum. Form follows function, and the function is heavy industry. 2062. We discover the zero-G advantage. We realize that heavy industry actually works better in space. On Earth, gravity ruins things. It causes sedimentation. It makes liquid metals separate like oil and water. It creates convection currents that disturb crystal growth. In orbit, we can mix alloys that are impossible to create on Earth. We start growing ZBLAN fiber optic cables that are 100 times clearer than glass. We print perfect silicon wafers for supercomputers, atom by atom. 2065. The data centers migrate. We realize that cooling server farms on Earth consumes massive amounts of energy and fresh water. In space, the shade is absolute zero, and the sun provides infinite power 24 hours a day. We build server reefs in orbit, massive constellations of processors floating in the shadow of sun shields. We stop building data centers in the desert and simply beam the data down. 2070. The orbital population booms. These aren't just automated factories anymore. They are towns. Rotational habitats spin to provide gravity for the workforce. The space collar worker becomes a demographic. They are welders, engineers, and botanists living in the Lagrange points. They don't commute from Earth. They live on the new frontier, maintaining the machines that keep the planet below humming. 2075, the gravity well flips. This is the statistical tipping point. For the first time in human history, the tonnage of goods entering Earth's atmosphere exceeds the tonnage leaving it. The image of the space age changes. It is no longer a massive rocket struggling up on a pillar of fire, burning tons of fuel to lift a tiny satellite. It is a constant, gentle rain of heat-shielded delivery pods streaking down like meteors. 2078. The cargo in these pods changes. We aren't dropping rocks anymore. We are dropping finished goods. Supercomputers, MRI scanners, fusion reactor containment vessels, and thousands of kilometers of zero-loss power cables. The factory is now officially above our heads. 2080. The first domino of the terrestrial collapse falls. Lithium and cobalt mines in Chile and the Congo cannot compete with the asteroid flood. They go bankrupt. The open pits go silent. The exit begins. The last blast furnace on Earth is decommissioned. Smelting ore requires massive heat and produces massive pollution. It is now illegal and unprofitable to do this in a biosphere when you can do it in a vacuum for free. The heavy industry that defined the 20th century leaves the planet, allowing the Earth to begin its long process of healing. 2090, the Great Remediation begins. We use the new abundance of energy to run phytoremining projects, using plants to suck toxins out of the soil in old industrial zones. 2100. A time-lapse of the Earth shows gray scars turning green. Massive copper mines are flooded and turned into lakes. Forests reclaim the tiered edges of the pits. 2110. The energy grid retires. Space-based solar power reaches 90% of global demand. We dismantle the coal, gas, and nuclear plants. 2130. Cities transform. They stop looking like dark, neon dystopias and begin to look like gardens. With carbon-negative concrete and cheap asteroid steel, we build upward and inward. Earth becomes a biological preserve. 2150. We realize the gold wasn't the treasure. The mass was the treasure. We look at the hollowed-out husks of the asteroids we mined and see hulls. 2160. We return to the empty mines. We mount massive fusion thrusters to the equator of the rocks and spin them up. Inside, centrifugal force creates artificial gravity. 2180. We pressurize the centers, add water and soil, and create inverted worlds. These are no longer mines. They are homes protected by miles of solid rock. 2200. The timeline ends with a departure. We have healed the Earth, and we have used the bones of the solar system to build the vessels that now carry us to the stars. Asteroid mining was just the gestation period for civilization. We had to eat the eggshell to grow strong enough to fly.